Hello, it's Valentine from Simplistic, and in this reaction we're going to look at how to calculate the value of Kp, and what's given to us is the value of Kc. So the first thing we need to know is that Kp is equal to Kc times RT raised to delta N, and R is equal to the ideal gas constant. T is equal to the temperature in Kelvin, and delta N is the change in number of moles between reactants and products. Okay, so let's see if we can apply this. So we know what Kc is, so we'll just go ahead and write this as Kc is 6.2 times 10 to the power 2, and this whole thing is multiplied with R. R is actually the ideal gas constant, which is 0.08206 liter atmosphere. We can just leave out this because in equilibrium constants units are not important. We don't write the units. So that's R, and then the temperature is 25. We change that to Kelvin, which is 273 plus 25, which is 298. So that's times 298 Kelvin. And then the whole thing is raised to delta N. So delta N, to find out delta N, all we have to do is look at the number of moles of product. So that's 2 out here, and subtract the number of moles of reactant. That's 1 out here and 1 out there. So delta N happens to be 2 minus 1 minus 1. Okay, which in this case ends up being, let me write this other part down, ends up being 0. That's actually a great thing, because anything raised to the power 0 is 1. So therefore this ends up being 6.2 times 10 to the power 2 times 1, which is the same as 6.2 times 10 to the power 2. And here's something important. Whenever you have a reaction where the total number of moles of product is equal to the total number of moles of reactants, make sure the reaction is balanced, okay, before you check. When the total number of moles of product is equal to the total number of moles of reactants, then Kp is equal to Kc. And as you can see in this problem, the way we worked it out, the value of Kp ended up being 6.2 times 10 to the power 2, which is the same value that Kc was. Okay? All right, so that's how you solve this problem. I hope that made sense. Thank you for watching.